Plate tectonics. The plate tectonics theory. When you blow a balloon, the balloon expands. The balloon gets larger. Similarly, if ocean crust continually forms mid-ocean ridges and is never destroyed. Earth's surface should be expanding, but measurements of the planet show that Earth is not getting larger. How can this be explained? Geologists proposed a more complete theory in the late 1960s. It was called the plate tectonics theory. The theory of plate tectonics states that Earth's surface is made of rigid slabs of rock or plates that move with respect to each other or in relation to each other. This new theory suggests that Earth's surface, the lithosphere, is divided into large pieces of rock. These pieces are called plates. Each plate moves slowly over Earth's hot and semi-plastic mantle. The word tectonic describes the forces that shape Earth's surface and the rock structures that form as a result. Plate tectonics explains why earthquakes occur and volcanoes erupt. When plates separate on the seafloor, earthquakes erupt. Earthquakes result and the mid-ocean ridge forms. When plates come together, one plate can move under the other. This causes earthquakes and creates a chain of volcanoes. When plates slide past each other, earthquakes can be result. Tectonic plates. Earth's surface is divided into ridges that move relative to one another. Look at the map above. It shows Earth's major plates and their boundaries. Notice how such boundaries are not in the middle of the ocean. Many of these boundaries are located at the mid-ocean ridges. The Pacific plate is the largest plate. The Juan de Fuca is one of the smallest plates. Earth's outermost layer are cold and ridges compared to the layers within Earth's interior. The cold and rigid outermost rock layer is called the lithosphere. The crust in the solid uppermost mantle is from the lithosphere. The lithosphere varies in the thickness. It is thin below mid-ocean ridges. It is thick below continents. Earth's tectonic plates are large pieces of lithosphere. These plates fit together like the pieces of a giant jigsaw puzzle. Directly below the lithosphere is a very hot part of the mantle. This layer of Earth is called the asthenosphere. Even though it is solid, the asthenosphere behaves like plastic material because it is so hot. The asthenosphere flows below Earth's plates and enables the plates to move. The way in which the lithosphere and asthenosphere interact help explain plate tectonics. Plate boundaries. Imagining placing two books side by side. Imagine each book is a tectonic plate. The place where the edges of the books meet represent a plate boundary. How many ways can you move the books along a set of boundaries? You can pull the books away from each other. You can push the books together. You can slide the books past each other. Earth's tectonic plates move in much the same way as you can move these books. Divergent plate boundaries. A divergent plate boundary forms where two tectonic plates separate. Divergent means moving apart. Mid-ocean ridges are located along divergent plate boundaries. When the seafloor spreads at a mid-ocean ridge, lava erupts. As the lava cools and hardens, it forms a new oceanic crust. As the process continues, the plates move away from each other. Divergent plate boundaries can also exist in the middle of a continent. At these boundaries, continents pull apart and a rift valley forms. The East African Rift is one example of a continental rift. The San Diego Andreas Fault in California is a transform plate boundary. A transform plate boundary forms where two tectonic plates slide past each other. As they move past each other, the plates might get stuck and stop moving. Stress builds up where the plates are stuck. When this stress is too great, the rocks break and suddenly move apart. The result is a rapid release of energy in the form of an earthquake. Convergent plate boundaries. A plate boundary forms where two plates collide. The denser plate sinks below the more buoyant plate in a process called subduction. A subduction zone is an area where a denser plate descends into arcs along a convergent plate. Boundary. The two types of convergent plate boundaries are ocean to continent and continent to continent. Ocean to continent boundary: when a dense oceanic plate and less dense continental plate collide, the oceanic plate subducts or sinks under the edges of the continental plate. This creates a deep ocean trench and a line of volcanoes form on the edge of the continent. This process can also occur when two oceanic plates collide. An older and denser oceanic plate will subduct beneath a younger ocean plate. A deep ocean trench forms along with a line of volcanoes. Continent to continent boundary. Convergent plate boundaries also form when two boundaries collide. Neither plate is subducted. The less dense plate folds and deforms, forming mountains such as the Himalayas in India.